I want to show you how to build a .NET Core app on your Raspberry Pi using Docker. Now if you head over to blog.alexellis.io, you're going to be able to find this blog post published on the 27th of October. Now you can actually build code on your PC for .NET Core and run it on a Raspberry Pi. I'm going to show you how to do that. Now the prerequisites are that you need a laptop or a PC. I've actually got a Mac here and a Raspberry Pi 3. We want Visual Studio Code installed and we need some tooling as well. So what I've done is I've just detailed the things we need, and the first one is Docker for Mac or Windows. So up in the right hand side you can see I have Docker for Mac running already. If you don't have that, you can get it from the store. Visual Studio Code, which you can download from this link, and then .NET 2.0 SDK. Now I've just finished installing that on Mac, and there's step-by-step instructions that you can follow through on the .NET website. So as soon as you've installed the .NET Core SDK, you're going to get a couple of commands. One of them is the .NET command. You type it in to check that this worked. And so we can see we've got 2.0. So the first thing we want to do is create a new directory. We just call it PySharp. And if you're on Windows, the commands are going to be very similar to this. And there's nothing in there yet. Now the .NET command actually allows you to scaffold a complete application by typing in .NET new. And so what we can do is, it says here, list the available project types. Type in .NET new. And it will show us we can create a console application, XUnit tests, class library, .NET, ASP.NET Core, etc. Now for this tutorial, what we're going to do is we're going to create a console application. We can build it on our PC, transfer it to our Raspberry Pi, and then run it. So let's start off with calling it PySharp. We'll write this in C#. And the first time you do it, take a couple of seconds. It's doing a .NET restore. And you see it took way less than a second. We've now got a project file and a bunch of other things too. So let's open up the code in Visual Studio Code. And we'll see inside the folder we've got program CS and PySharp. Now it tells me that it's recommended to install the extensions. You probably want to do that too. And if you need to add any project references, etc., you can do that in line in the editor, or you can also do that on a command line. But right now we're just going to change the message here. I'm going to check what the blog has asked us to put. So I love Raspberry Pi. Now there's actually a built-in console in Visual Studio Code as well as the normal terminal. And we'll run once we're in the folder, and that will build the code really quickly in a debug way, and it will run it. When you come to publish that to production, use a .NET publish command, and that will create your DLLs. So here we've got the message, and we've been able to run our .NET code on our PC. But there's a bit of a problem for when we want to run that on the Raspberry Pi, which is that there's no SDK that can build the code on the Raspberry Pi. So what we can do is build the code on our Mac or PC using a Docker image, transfer it to the Raspberry Pi, and just use the runtime on its own. What we're going to do now is take my Docker file, which you see from the first instruction uses the official .NET 2.0 SDK for a PC, adds the C# code in, does a restore and a publish, and then this is the bit that's kind of different. We're going to cross-compile to Linux ARM. So if I actually use this Docker file on my PC, I wouldn't be able to run this. But by putting -r Linux ARM, we can actually then take the DLLs that come out of that and run them on the Raspberry Pi using the runtime. Now this Docker file actually has two from instructions. That's because it's a multi-stage build. And multi-stage builds allow us to build using one image and ship it using another. And most of the time it's because we want a smaller Docker image. Okay, in this instance, we're actually using it to cross-compile. What we need to do is create a Docker file over in our project and put this code inside, and then we should be able to do the Docker run or Docker build like this. Now I actually already have done this, so I'm going to build it as 0.2 this time. That's now been built, and we can push this to the Docker Hub. The Docker Hub is a place where you can share images. Now, let's say you had something that was confidential or that was secret. The Docker Hub allows you to pay some money to have a private repository, which means it's hidden from everyone else. Your other option is to run your own registry inside your network, and you can find instructions for that on Google. So actually what we can see is there's around 5 layers here that are being pushed up to the Docker Hub. Now each of those layers represents a different part of the program. So if you were to only change the program CS and republish, we wouldn't need to reship all 6. We're just going to change the ones that have our code in it. So while that's running, let's connect to my Raspberry Pi, which I have on my local network. And we will be able to pull down the image and run it. Now, when I was on here earlier, I ran it with 0.1, which was just what I said I built earlier. You'll see Docker run, hello world, and it's a little bit slow to start, but actually once a program is in memory, once it's running, be quite quick to process subsequent commands. So as soon as our image is pushed up, we can actually change this to 0.2, and what we're actually looking at here on the left hand side is my username, the name of the image on the Docker Hub, and then the 0.2 on the other side. And at any point, what you can actually do is to head over to the Docker Hub, and you can look at your image and what tags you've got. This will also give us a good idea of how big that image is that's been pushed. So we can see under the tags, so pushed up 34 minutes ago, it's actually about 90 megabytes, and 0.2 is just finished. Let's refresh it. And we'll see the second image there. So let's run 0.2, and this will start downloading. We can see some messages here saying that the layer already exists, which is great. And this is part of the benefit of using a Docker image format, because parts that have already been shipped don't need to be shipped again unless they've changed. There we go, so they're roughly the same size. And as soon as this is finished downloading, we'll see the new version of the program running. Now, I've set a few challenges here for people. The first challenge is to, instead of doing a .NET Console app, is maybe try to do a ASP.NET Core application. Now that will also require you to expose some ports in your Docker file when you do your Docker run. And that might need some additional learning, but there's plenty of resources online. Challenge 2 is to add a third-party dependency to your project with NuGet. Now that might be something like Newtonsoft JSON, or maybe your favorite logging library. And the third challenge, and this is a bit more of a weekend project, is to go ahead and build a Docker Swarm or Kubernetes cluster using my 3-part mini-series. Now Scott Hanselman has been building one out, and I've been giving him some help, and he's actually running OpenFAS on it, which is a serverless framework. And it allows you to build out tiny functions, perfect for a Raspberry Pi, and then run them across all the capacity that you've got. Now, just to wrap this up, we've been able to overcome a shortcoming in the tooling. So for whatever reason, there is no way to build .NET Core on the Raspberry Pi right now, or it's just not practical. But we can build on the PC, we cross-compile the code, and then we're able to just push that to the Docker Hub using a single workflow, pull it down on the Raspberry Pi, and I can actually see right now it's saying I love Raspberry Pi. And if you want to know a bit more about Docker, Raspberry Pi, or how to build your own swarm, head over to the blog and show us what you can do.